We want to solve a triangle in which none of the angles are given. It's a side-side-side triangle. So we want to find the measurement of angle A, angle B, and C. With this kind of problem, we must use only the law of cosines first because there's not enough information to use law of sines. We don't have an angle given that's opposite a given side. So now it doesn't matter which side we want to go for. So we'll just pick one, and that's going to determine which of the three law of cosines formulas we're going to use. So let's go for A first. So A squared is going to equal B squared plus C squared minus 2BC cosine A. These lowercase letters are going to be opposite the uppercase letters. Okay, so the lowercase a is going to be opposite the capital letter A. So this is 4 here. So 4 equals, the B is going to be 3. And then the C is going to, lowercase c is going to be 6, since that's opposite the capital letter C. Now we're going to put in the 3 and the 6 here as well. And now we need to solve for cosine A. So we just need to simplify this. 16 equals 9 plus 36. So we have minus, this will be 36 also, cosine A. Now be careful, there's no like terms here with these second two. The first two are like terms, but these second ones are not. So we need to isolate this part that has the cosine in it. So I'm going to subtract the 9 and the 36 over to the other side. So 16 minus 9 minus 36 is going to give us negative 29 equals negative 36 cosine A. Now we're going to divide both sides by negative 36. And that's going to give us a decimal here. We get 0.8055, but there's going to be some more decimals after that. So I'll just put ... to indicate that that keeps continuing. Cosine A. Next thing we want to do is take the inverse cosine of both sides here. So I want to do inverse cosine of 0.8055, and that's going to give us the measurement for angle A. And when we do this, we're going to get the first answer of 36.34 degrees is going to be our measurement for A. Now, I mentioned this before previously, but we're only going to get one answer when we take the inverse cosine. Again, the reason why that is because cosine is only positive in the first and the fourth quadrants. So the first quadrant is where this one comes from, 36.34. Now we do get a secondary solution, but it's going to occur in the fourth quadrant. So an angle in the fourth quadrant is either going to be negative or it's going to be an angle between 270 and 360, which we can't have in a regular triangle. The triangles have an angle only between 0 and 180. So I know with confidence that 36.34 is the only solution we have for the measurement of angle A. So we can do the same thing, and we can use the law of cosines to find angle B, and that's what I most recommend that you do. Now, instead of doing that, I'm actually going to show you what would happen if we choose to use the law of sines instead. So I'm going to take us down a very specific pathway here to get to a conclusion that I want to show you. Okay, so let's suppose we want to use law of sines. That means that we can, because we have a given ratio. We have sine 36.34 over 4. That's a given ratio that we now have because we found the measurement of angle A. So now I can use this with law of sines to find measurement of angle B or angle C. Now I'm going to purposely go for the measurement of angle C I want to find. Again, I'm doing this specifically to take us down a unique path that's here. So now let's cross multiply. 6 sine 36.34 equals 4 sine C. Divide both sides by 4. And then we're going to put this into the calculator. When you do, you're going to get 0.8889. There's some more decimals that continue, so I'll do ... again for that. And then we have sine C here. We need to take the inverse sine of both sides. Now, when we do this, we are going to get two answers because it's the inverse sine, because sine is positive in the first and the second quadrant. And so that we will get two possible solutions. The first one is what the calculator gives, and that's going to be doing that. We're going to get 62.73 degrees. But we have a secondary solution. Automatically, you're going to subtract it from 180 because, again, that's the reference angle formula you would use for the second quadrant there. So 180 minus 62.73 degrees. And we get the secondary solution, 117.27 degrees we get for this. Now, there's a very unique thing that happens, which is why I wanted to take you specifically down this path. By going down this path, we actually got the wrong answer first, because the way this triangle is drawn here, the picture shows that angle C needs to be an angle more than 90 degrees. It's obtuse angle, and that would tell us that we would need to pick 117.27. Now, here's a problem with that. Let's suppose the problem never gave us a picture. It just told us simply that what these three sides, side A, side B, and side C were, and you have to draw your own triangle. You would have no way of knowing whether the triangle needs to be drawn this way or if it's drawn as an acute angle between 0 and 90. So you would not know how to do that. So that's why I recommend that you don't use the law of sines. Just use the law of cosines twice when you have a problem like this with side, side, side. Then it avoids any kind of confusion in the answer you'll get right away. In fact, I'll go ahead and I'll show you what happens if you use the law of cosines directly. Now, if you're going to use the law of cosines, that means we have to use specifically this formula, c squared equals a squared plus b squared. And then we're going to do minus 2ab cosine c. And I'm going to solve this and show you that you're going to get exactly the same result. In fact, we're going to get the 117 angle directly and avoiding this confusion of wondering which one of these is the correct angle. All right, so now let's put the information in on this. So we have 6 goes here, and I have 4 squared plus 3 squared for that. I have 2 times 4 times 3, and it's a minus here, not an equal sign, so I have minus 2 times 4 times 3 cosine c. 6 squared is 36 equals 16 plus 9 minus, so we multiply this out, and we're going to get a 24 cosine c here. Again, these are not like terms, so you want to do 36 minus 16 minus 9. And so by going through all that, we're going to get from this 11 equals negative 24 cosine c. We're going to divide both sides by negative 24. That look more clear, minus 24. And by doing so, we're going to get negative 0.4583. Again, there's some more decimals there, so I'll put the dots there for that. Cosine c. We're going to take the inverse cosine of both sides. And as I mentioned earlier, whenever you take the inverse cosine, we're sure we're only going to have one answer. When we do that, we actually get 117.28 we get for C. Now, these are very, very close here. The only reason this one's off by slightly is because we're using a rounded answer, which is another reason why you might want to use law of cosines, because that way you're not using any rounded answers on that. Here we use 36.34, and that gave us a slightly different answer. But again, they're both essentially the same. But let's put 117.28 in here for measurement of angle B. All right, now we have the last one, measurement of angle C. And we just do that by subtracting everything from 180. There's no reason to use law of sines or law of cosines for this one. So down here, we're going to use measurement of angle B is going to equal 180 minus 36.34 minus 117.28. We're going to use this version because we know this one's going to be more accurate because we used actual numbers in here and not an estimation like we did before for law of sines. So if you subtract all that, we get the measurement of angle B is equal to 26.38 degrees. And so now we have all three of the angles. So I'll put that up here. 26.38. This triangle is now solved because we've now solved, we know all the sides were given to us, but now we know all the angles. So we're done.